Welcome to my video channel. Today we discuss part 6 of the chapter Theory of Quadratic Equation. It is for preparation of JEE Main and Advanced and for different state level joint entrance examination. Today our problem is problem number 26. Problem is if ax plus by is equal to 1 and cx square plus dy square is equal to 1 have only one set of solution, then which is true? Number 1, ad square plus bc square is equal to cd square. Number 2, a square d plus b square c is equal to cd. AD plus BC is equal to CD. AD square plus BC square is equal to C square D square. So actually the problem is one linear equation involving x and y is given. So if it is solvable, then it has a pair of solution, one for x, one for y. And this is cx square plus dy square is equal to 0. It is second degree. So if solvable, then they have two pair of solution. But in this problem, it is given that if these two equations have only one set of solution, then which one is true? So actually we are given that these two equations have only one set of solution. Acha, before starting the problem, I like to tell one thing. I have started this problem in my last video class, part 5. But in that part, actually, I have wrongly copied the problem. I have copied cx square plus dy square is equal to 0. In fact, it is 1. So now I start the problem. So eliminate y from this and that. This is y actually equal to y 1 minus ax by b. Put it there. Cx square plus d into 1 minus ax by b whole square is equal to 1. So that b square cx square plus d into 1 minus ax whole square is equal to b square. That is b square c into x square minus a square d into x square. So I take this and that minus 2adx plus d minus b square is equal to 0. This is a quadratic in x. So in general, it has two solutions. But given that these two equations have a one set of solution, so from here it must have one value of x only. It means that this equation have roots are equal, and the required condition is discriminant is equal to 0, that is 4 a square d square is equal to 4 into a into c. 4 cancels, so that we have a square d square is equal to, I multiply with d first, b square cd minus b square minus a square d plus a square d. You see, b square cx square into a square dx square. Sorry, this should be plus. So it is, once again it is plus. So it is a square d square is equal to b square cd plus a square d square, then multiply with minus b square, minus b to the power 4 c minus b square a square d. Now a square d square cancels from both sides. So we have b, this b square c into d is equal to this and that. That is b square a square d plus b to the power 4c is equal to that. From both sides, b square can be cancelled. So we get a square d plus b square c is equal to cd. This is our answer. And it matches the option number B, second option. A square d plus b square c is equal to cd. So option B is correct answer. Next problem. Oh, next problem is problem number 27, and it is if p comma q are roots of x minus a into x minus b plus c is equal to 0, then AB are roots of what? AB are roots of which equation? Option x square minus p plus q into x plus pq minus c is equal to 0. Next one, x square plus minus p plus q x plus pq plus c is equal to 0. X square plus p minus q into x minus pq minus c is equal to 0. 1, 2, 3. And other is x square plus p plus q into x plus p q plus c is equal to 0. Next, Actually, uh, let us discuss the problem once again. PQ are roots of that equation. In fact, it is a quadratic equation. It has two roots, and roots are P and Q. Now we have to find in that condition AB are roots of which equation among the following. That the given equation is, you see, this one is x square minus a plus b into x plus ab plus c is equal to 0. But given that P and Q are roots of that, therefore we must have P plus Q is equal to P plus Q minus B by A, so that A plus B, and PQ product is equal to this by 1, so AB plus C. Now to find the equation whose roots are A and B. So required equation is x square minus sum of the roots into x plus product of the roots is equal to 0. Now a plus b is equal to p plus q. So it is x square minus p plus q into x plus ab. AB is equal to pq minus c. This is our answer. And in fact, it is first option is correct. X square minus p plus q into x plus pq minus c is equal to 0. Next. Next problem is problem number 28. Roots of the equation 10c6 x square minus 2 into 10c5 x plus 10c4 is equal to 0 are: number 1, real and equal. Imaginary. Then real and distinct. None of these. Straightforward question. One quadratic equation is given, and we have to find whether this quadratic equation have real or and equal root or imaginary root, and so on. Actually, we have to study the discriminant of the quadratic equation, which is b square, that is 4 into 10c5 b square is equal to 4a, means 10c6 into 10c4. 4 cancels. So actually it is equal to 10c6 into 10c. This is nothing but 10c6, this one also. So it is actually equal to 10c6 whole square. Therefore, now from there this is equal to that. So 1 discriminant. So discriminant is this minus that. Just 1 minute. Discriminant actually equal to discriminant is equal to b square into 10c5 whole square b square minus 4 into 10c6 into 10c4. But 10c4 is nothing but 10c 10 minus 6 4, that is 10c6. So that d is equal to 4 into, now take 10c5 whole square common, 10c5 whole square into 1 minus 10c6 by 10c5 whole square is equal to 4 into, you see, 10c5, 10c4, 10c2, always positive. This is positive. So 10c5 whole square into, now we have to see whether this is positive or negative. It is 1 minus 10c6 by factorial 10 by factorial 6 into factorial 4 by whole divided by factorial 10 divided by factorial 5 into factorial 5. Its whole square is equal to 4 into 10c5 whole square, 1 minus factorial 10 cancels, so that factorial 5 into factorial 5 by factorial 6 into factorial 4. So that 4 into 10c5 whole square, 1 minus, this is 1 by 6. They together is 1 by 6. Factorial 5 cancels. And they together is 5. It is 5 into factorial 4. That factorial 4 cancels. So now you see this is positive and 5 by 6 is less than 1. So this is positive. So we get discriminant is positive. Therefore, roots are real and distinct, real and unequal. Option C is our answer. Next. Next, problem number 29. And 29th problem is PQRS are all real. They are all real. And PR is equal to 2 times Q plus S. Then at least one of the equations, number 1, x square plus px plus q and x square plus rx plus s is equal to 0 have imaginary roots. Number 2, number B, one positive and one negative roots, real roots, none of the above. Okay, let us see what is the exact problem. Given that P, Q, R, S, these four quantities are real, and a relation between P, R, Q, S is this. P, R is equal to 2 times that. Then at least one of the equations, this and that, have imaginary root, one positive, one negative root, real root, and fourth option is none of the above. Let us study the discriminant of this and that. Say d1 is the discriminant of that is equal to p square minus 4q. d2 is the discriminant of the second equation. It is r square minus 4s. Now let us see what is d1 plus d2 is equal to p square plus r square minus 4 into q plus s is equal to p square plus q square. Given that 2q plus s is pr, so this is equal to 2 times that, so 2pr. 2, oh, just 1 minute. Q plus S is PR. It is, it is. PQ is equal to that. PQ is equal, no, no, just a minute. Q is there. So just 1 minute. Once again I read the problem. X square plus px plus q is equal to 0, and x square plus rs plus s is equal to 0. d1 is equal to p square minus 4q, d2 is equal to r square minus 4s, d1 plus d2 qs, so that p square plus q square, oh, this is p square plus r square minus, given, this is given, actually I write the actual one, PR is equal to QS. Given that this is real and PR is equal to 2 times Q plus S, it is actually given. So now I consider D1 and D2, and sum of the discriminants is equal to D1 plus D2 is equal to this plus that is equal to P square plus R square minus Q 4 times Q plus S is equal to P square plus R square. This is 2Q plus S is equal to PR. 4Q plus S is equal to 2PR is equal to P minus R whole square, and it must be positive. Positive or equal to 0 if they are not equal. Okay. The sum of the discriminant of this and that is positive or 0. If sum is positive, at least one must be positive, either this or that, must be positive because sum up to negative cannot be positive. So at least one of d1 and d2 is positive. So at least one of the equation have real roots. So option C is correct. Next problem. Problem number 30. If ax square plus bx plus 6 is equal to 0, this is not b, 6 is equal to 0, does not have real root. If this equation does not have real roots, AB real, then to find least value of 3a plus b. To find least value of that, options 2, 3, minus 1, minus 2. তাহলে we have given a quadratic equation, this, and given that it does not have real roots, so its roots are imaginary, so its discriminant is negative because it does not have any real root, so imaginary root, so discriminant is negative, that is b square minus 4ac is negative, that is 24a taking to that side is greater than b square, that is a is greater than b square by 24. Now we have to find least value of that, 3a plus b. Now using the value of a from here, 3a plus b is equal to 3 into that is b square by 8 plus b is equal to b square plus 8b by 8 is equal to b square plus 8b plus 16. To make it perfect square, I take 16, adjust by 8. So it is equal to, this by 8 is equal to b plus 4 whole square by 8 minus 2. Oh, I am mistaking again and again. 3a plus b, instead of a, I write greater than b square by 24. So this must be greater than this. So this is that. So 3a plus b is greater than this minus 2. This is positive. This is positive. So this is positive. So least value is minus 2 because it is either minus 2 or plus something. But least value would be minus 2. So minus 2 is our answer. Option D is correct. Next. If ratio of roots of, problem number 31, if ratio of roots of x square minus px plus q is equal to 0 is n is to n, then quantity q into m plus n whole square is options pq mn p square mn q square mn p q m. Once again, quadratic equation is given, and given that a ratio of its roots is m is to n. That is, its roots are, if one is m alpha, other is n alpha. Ratio of roots is m is to n. So we must have sum of the roots, that is m alpha plus n alpha is equal to p, and product of the roots is m n alpha square is equal to q. Now we have to find a relation between q, m, n and pq, etc. So alpha to be eliminated. From the first one, m plus n into alpha is equal to p. To eliminate alpha from this and that, I mean this and that, oh, square it. So m plus n whole square alpha square is equal to p square. Now putting the value of alpha square from here, it is equal to m plus n whole square into q by mn is equal to p square. So that we get m plus n whole square into q is equal to p square mn. And this is our answer. This is equal to p square mn. P square mn is this. So option B is correct. Okay. With this, I stop here today, and I request you to like, share, and subscribe my video. Thank you.